So what we're going to talk about here is this idea of test-driven development for API security. And the idea really is how we can take some ideas of test-driven development and apply them to API security testing to improve our API security posture. The idea is to be able to apply this continuous process of improvement to our APIs by writing some tests and running them forever. It has some consequences for shifting left on API security, and so we're going to see all of those things. My name is Jose. I work at APISec. I'm the guy who writes the tests, actually. So if you're a user of the tool, even if you're not a user of the tool, if there is something you would like to see on APISec, on the platform, on the scanner that is not there, that you don't think is working correctly, any gaps, Dan just announced we're going to have this beating the scanner challenge, right? So either through that challenge or through a different channel, if there is any feedback you would like to give me, please do so, because I really appreciate and it really helps a lot. I'm the author of 2 books. One of them is Microservice APIs, was published at the end of 2023. And I'm now in the final stages of finalizing Secure APIs. We're going to raffle 5 ebook copies of Secure APIs after the conference among all the attendees. And if you are not one of the winners, you can still get a 45% discount on any of the 2 books by using this discount code. It's going to appear also at the end of the presentation, so don't worry if you can't get it now. The QR code will give you the link to one of the books on Manning website. I have a channel on YouTube where I publish content about APIs and API security, so that's something you can subscribe to if you want to stay up to date with that content. And if you would like to connect with me, you can do it in various ways. I'm still available on Twitter or X if that platform suits you. I'm on YouTube. You can drop me an email at my APISec account. You can check out my projects on GitHub. So I try to keep it up to date with examples and building APIs, securing them, and things like that. I have a newsletter, and you can connect with me on LinkedIn as well. So so that's about me. Now, what's the agenda? We're gonna see how TDD can help us, what kind of inspiration we can take from TDD to improve our API security testing process. When you walk away out of here, I want you to have some takeaways that you can apply right away in your job to improve your APIs and start testing them in a better way, from a security standpoint. So if I accomplish that, that's my job done. So we're going to see how we can bring some of those ideas of test-driven development to API security. We're going to see what the implications are for shifting left on security, why that's a good idea, and why we want to do it. We're going to see how threat modeling can help us in this process of figuring out what to test, where do we start, how do we test, and so on. We're going to see how we can create some minimum viable tests. So that's a cool idea to see, how we can create a simple test that drives a lot of value for our API security testing. And finally, we're going to see something more complex, like tackling testing and fixing vulnerable business flows. If you have any issues, please put it in the comments. I want this talk to be helpful both for developers and for penetration testers and QAs. So this talk should be useful for people who are building APIs, and it should help you to get in a position where you can write better unit tests for APIs. If you're a penetration tester or QA, it should help you automate the boring stuff, the boring parts out of testing APIs, so that you can focus on the interesting parts. So that's the idea. So shifting left on security. So we're talking about test-driven development. The whole idea of this is to shift to the burden of testing and applying QA on our assessments on our applications. So the idea is to automate the process, right? Instead of having to do this every once in a while, we write the test once and we'll run it forever. Whenever we have to write some new code, merge it, release it, build it, we run the test again. We ensure that we are not replicating those errors from before, and we are not having any regressions. As an example, imagine we have an API and we have to expose some new capability. Imagine it's some kind of insurance, payments, or e-commerce. We're going to expose some capability to allow customers to return an item and claim a refund. So of course, we want to make sure that the capabilities we expose to the API are exactly what the business requirement is, right? So a customer purchased something and they will claim that specific refund. They're not going to be able to claim refunds for things they didn't purchase. They're not going to be able to claim refunds for negative amounts of items. They're not going to be able to claim a refund for 10 times the value of something they purchased before. The point here is to write tests that allow us to ensure that the implementation of the test is up to the business specification, and it doesn't leave any loopholes or gray areas in the implementation that can be exploited by threat actors. So why do we want to do this? Why do we want to shift left on security and do this testing early? It looks like it's going to hold us back for a while. We're going to have to spend some time assessing security, writing tests. Is there any benefits to this? And the answer is there is actually a lot of benefits. So for those of you who joined the industry maybe a little bit more recently, most of the modern standards on modern software development go back to these DevOps reports that were published from the mid of the 2010s, from 2015. So the State of the DevOps report by DORA. The original research in those reports found, among other things, that shifting left, testing, QA, security really drives a lot of value for development teams. It means you deliver better software with less bugs, less security issues. You develop faster in the end, and you spend less time fixing issues because you tackle those issues from the very beginning. So check out, there is 10 years ago. This is still very, very relevant for today. So check out those reports, really give you a lot of insight. So what they found, you end up spending 50% less time addressing security issues. And this makes a lot of sense if you think about it. Like if you're building an application and you don't build security into the application from the very beginning, you may end up in a situation when you do a QA or security assessment at the end, you may discover that there is something in your architecture that is flawed and it's open to certain types of exploits. And if this feature is core to the architecture of your application, it's really not easy to come back and change that. You're not going to be able to. What you're going to have to do is to put patches and hack some solutions in front of your application to make sure that those exploits don't leak through the interface. And this is what we call bolt-on security, right? You have bolting security onto the application because you didn't build security into it from the very beginning. So why bolt-on security doesn't work? Let me illustrate with a very simple example. Imagine we have an endpoint which is get products. So we call the endpoint, we get a list of products. Imagine on an e-commerce website, for example. And we have a query parameter, which is sort by, and it allows us to filter, to sort products by a certain criteria. Now we look at the spec here. This is the design of our API from the very beginning, and we see, all right, so sort by is a string, it's non-required, and that's all we have. And if the implementation really follows on from this, with a security assessment at the end, we may find that because there are no constraints on the input, users may be able to send some malicious SQL injection statements through this parameter. And depending on the implementation, maybe it turns out that we are vulnerable to SQL injection attacks. That leaks into the code base, it goes to the database, and it ends up in a really bad situation. So we find this during the QA assessment at the very end of the development process, and the report comes back, and we have to address it, right? Now, when we are addressing this problem at the very end of all those iterations, we probably don't remember what was the context of this, what was the original intention of, in this particular context, isolated now. So we say, okay, we're going to try to prevent SQL injection statements with some sort of regex here. And that's the bolt-on security approach. It's not easy, it means we still have to go back to the beginning of the process, redesign the API, include this new constraint on the parameter, do the implementation. We have to retest, do the QA and security assessment at the end. And we may find additional issues. That's when this slows us down because we didn't build security into the software at the beginning. We end up doing a lot of iterations until we get this right. The alternative approach is we get this endpoint design at the very beginning of our API design process, and we do some threat modeling on it. We sit down and we think, okay, what can go wrong here? So we look at this parameter and we say, like we said before, right? It's a string. Well, what happens if we send a SQL injection statement through this? And it turns out, well, this is a possible attack, actually. Is there anything we can do here to constrain that input to prevent it? And because we're designing the API at that very moment, the application, we are looking at the database schemas and all of those things, we realize, well, sort by is intended to be used with two values, price or reviews. So let's just constrain it that way. It's a simple enumeration. And so this is how we do security by design. And so we do this from the beginning. We don't capture this problem at the end. We have less iterations in the QA and security assessment process. We deliver faster. We have more confidence in our security posture. Now the question is, this works. This is a very simple example, and it works if we are at the very beginning of the API development process. In practice, all of you are going to have hundreds of APIs with hundreds of endpoints, if not thousands, and maybe not a lot in the way of API security tests. So what do we do? How do we start testing this? And so the best way to do it is with a threat model. A threat model, analyzes the possible attacks against our APIs, how they happen, and how the attacks are carried out, what the outcomes of those attacks are. And once we have the full analysis, this is our roadmap, really. What we have is an idea of what are the most impactful attacks we have on our APIs, how they happen. We will find some common input vectors among those attacks, and we will find the most impactful attack vectors that we have to address. And that's where we start. We start putting tests for those things. We start putting fixes for those things and making sure that we don't have any regressions. My experience, developers don't have a lot of experience in threat modeling. If you are one of those persons that don't have a lot of experience, I cover this in my book, Secure APIs, but there is more you can do to learn about this. So OWASP released this card game called Cornucopia. So this is to get development teams familiar with the process of threat modeling. The idea is you give a hand to a bunch of people, so front-end developers, back-end developers, infrastructure, SREs, stakeholders, business stakeholders. So we'll sit all together. We're going to have these cards. They describe possible attacks against our applications. So we read the card, we read the problem, we analyze it together from different perspectives. And by doing this exercise a few times, we're going to get comfortable with the process of threat modeling. And at some point, it's going to be second nature. We're going to come up with our own scenarios and ideas on what could go wrong with our application. Then you can look at some standard models of threat modeling. So one of the most popular ones is Stride. So Stride is a threat modeling framework created by two employees at Microsoft in the mid-90s or something like that. It gives you 6 categories around which you can describe attacks against your applications. One of them is spoofing. If there is a threat actor spoofing on the network, maybe they can steal credentials from the user. Then what happens then? Can they use those credentials? Are those credentials going to be long-lasting? Is the security requirement of your application such that you have to be able to prevent threat actors from using credentials of other users? There are some standards to prevent these things, like MTLS for certificate-bound tokens, demonstrating proof of possession. So you can do those kinds of things. There's tampering. Can users tamper payloads, URLs, things to trick users into ending up in situations where they become vulnerable to certain types of attacks? Repudiation. Can you trace actions to specific users? Information disclosure, all different kinds of data leak that we may have in the API across different endpoints. Denial of service, that can happen through various types of endpoints and operations, even in pagination attacks. Elevation of privilege. Can users assume roles that don't belong to them through various ways? So this is a way to structure your work around threat modeling. And if you want to know more about this, the one reference about this is threat modeling by Adam Sostak. And by the way, he runs workshops on threat modeling in OWASP conferences every year. They are impressive. And check out also the threat modeling manifesto to give you more ideas on how to do this. So now, enough of this theory. Now, how do we apply this? Let's do some simple exercise. So imagine we have an e-commerce platform, and the flow of our users is very simple. They go from the beginning by checking out the catalog of products. So they are going to see which products are available, and then they're going to be able to check out the details of a product. They're going to be able to add this product to the cart. They're going to be able to check out the cart, calculate the price, pay. Then that's going to result in an order that is placed. They're going to be able to check the details of the order, the state of the order. Eventually, the order is returned, and they can return it. They can claim a refund and things like that. So imagine we have this sort of flow. And now the question is, what can go wrong here, right? The the best threat models don't really focus on endpoint by endpoint, but they look at the business flows in your application. And this makes a lot of sense because we're going to say more of this in a moment. But when you look at API breaches, the majority of API breaches happen in the context of flows or business application, business logic implementation flows. So this is what we want to look for, gaps in our implementation. A similar kind of flow you will find in Crappy. This is a WASP project that illustrates how application, the most common vulnerabilities in APIs. So you can check that out to get a similar flow. To give you an idea of what the flow looks like, we may have this Open API specification, the catalog, the products with the ID, the card, and similar thing. To document the flow, we would Aratto. So Aratto is the standard these days to describe API workflows or user flows. So we didn't have something really in the past to describe what are the steps that a user needs to take to accomplish something with our API. This is one of the best things you can do for yourself. Describe the flows through your API with Aratto. The ecosystem around this spec is growing by the day. You're going to end up having tools at some point that you just give them the spec of the Aratto spec and they do the testing automatically. So right, we're going to start. We've done some threat modeling on what can go wrong. We're going to get some ideas. Let's begin with some minimum viable tests we can do here. So something that is very simple and is going to give us a lot of value. One kind of test you can do is broken authentication. So you know which endpoints are authenticated in your platform. Write a test that is just sending a request to the endpoint without credentials. This is a very simple test. It takes literally 5 minutes to write. Do it per endpoint. You can even automate the process of writing that. I guarantee you're going to find surprises. Like 50% of you are going to find something strange here. It may not be an exact, like a 100% vulnerability, like a breach, but it may be some sort of strange behavior in the API when you send a non-authenticated request. And that's something you have to address. What else can go wrong here? So we can look at this from two different perspectives. We can look at endpoint level vulnerabilities, and we can look at flow-based exploits. At the endpoint level, we're looking at things like, can we set an order? Can we place an order with a negative amount of items? Can we send a SQL injection statement? Can we overwrite server-side properties of an object? Like when we place an order, the order has things like the state of the order, it has an ID, creation date, and things like that. Are we able to overwrite some of that data when we place the order online? Or that would be pretty bad, right? If we can place an order and set the value directly to send or delivered, for example. There's a question on the GitHub project. I'll share the link later. If you search, if you Google Crappy or WASP Crappy, you will find that on Google. The more tests we can do, something very interesting in terms of minimum valuable tests, something like BOLA, broken object level authorization. So the concept is super simple. Can user A access data from user B? If you know your API, this test takes also like 5 to 10 minutes to write. You can do this for all those endpoints that have an access scope, which is resource owner specific. So if you have something like a payments endpoint, an orders endpoint, only the owner of the resource should be able to access that data. So write that test. This is literally what we do in APISec. It's more complicated because we have to account for more variability in API configurations and behaviors. But this is the essence of how the test works. It takes you 10 minutes to write this, and I guarantee you, 30% of you are going to find actual issues, and another 30% are going to find some strange behaviors, things that threat actors may be able to exploit to tailor an attack strategy to cause something bad in your API. Now, the real problem we want to look at is business flows. All of those things are really valuable, broken authentication, BOLA, SQL injection. But when you look at reports of API breaches and analysis of the current state of API security, you're going to find that most of the problems happened around business flows. And so it's the combination of various factors that allow threat actors or hackers to breach into an API. It's not just one thing. It's not like I find SQL injection and I can leak the whole data set. It doesn't usually work like that. It's more like I found that there is a non-authenticated endpoint that is leaking emails from the users. and then I can use this email in another endpoint to obtain more information about the user profile. So I can obtain maybe the home address, the phone number, and this endpoint also turns out to be non-authenticated. And then you can automate certain things here to produce an actual data lake.